Hello and welcome to ATARC's webinar series. Today, topic experts will share strategies that agencies can implement to alleviate the concern of the unknown and make operations more efficient. My name is Kirsten Kotsaruba, and I have the pleasure of moderating today's panel discussion. ATARC stands for the Advanced Technology Academic Research Center, and we are a nonprofit that facilitates collaboration between government, industry, and academia in order to accelerate technology modernization initiatives. We provide ongoing opportunities for cross-agency collaboration through on-site interaction, learning, and market research. I would like to welcome all of our attendees, and a special thanks to Stacy Barea and the entire Neo4j team. This afternoon, we are going to hear from our panelists, followed by a Q&A session. And we will also have a few polls come up throughout the webinar that you can answer and receive your CPE credits for attending today's event. So be sure to respond to the polls as they come up, and don't forget that you can submit questions of your own in the Q&A section of this platform. So now that that's all been said, I would love to welcome our panelists to please come on camera and go ahead and unmute yourself, because we are going to begin with a round of some introductions. I saw Duncan come off camera first. So Duncan, maybe you can start us off, please.
Yes, ma'am. Hello, I'm Duncan McCaskill. I am the Acting Chief Data Officer and current Chief Analytics Officer for the Department of the Navy. Department of the Navy includes the Navy Secretariat, the United States Navy, and the United States Marine Corps. We have the man, train, and equip missions for Navy and Marine Corps, as well as the care and welfare of the force. It's about 900,000, give or take, active duty reservists, civilians, officer, enlisted. And I am a longtime ATARC listener, first-time caller, and I'm very glad to be here. Thank you.
Awesome. We're really happy to have you here. Thank you. And let's go to Sumit next.
Hi, good afternoon, and I'm happy to be part of this discussion. I'm Suman Shukla. I'm the section head for the data management team in Copyright Product Management Division. We started with copyright modernization, and now we are all over the place, starting with the copyright data. Copyright data is the biggest repository in the world, and we have wealth of information, and which very much goes through the same concept that we're going to talk about, the silos. And I've been working with that for almost 6 years now in this capacity, and working on establishing enterprise business intelligence, data warehousing concept, establishing a data governance, data quality, data integrity, and also doing lots of digital asset management. Since Copyright Office have lots of paper documents, the registrations done in 18th century on paper are still sitting in drawers, and we're trying to digitize them, put them online, and extract data from them so that users don't have to literally walk into the building to see those registration documents. And they can, we successfully put 41 million records online so people can look from the comfort of their home. So it's been a lot of going on here. Before that, I was a program manager at Office of Chief Technology Officer in DC government, doing similar job with data warehousing, business intelligence, and geospatial information, publishing data online and things like that. So I'm happy to be part of this discussion. Thank you.
Yeah, thank you so much. And we'll jump to Michael Gorman next.
Hey, good afternoon, everybody. It's great to be here. I am with the Department of Homeland Security, the USCIS, U.S. Citizen and Immigration Services, Office of the Chief Data Officer. I'm here on behalf of Beth Puchek, our CDO, and just adding to the themes that I've heard from the two other panelists here. Definitely have a lot of work on the analytics side of the house going on right now, really trying to bridge the gaps and work better in the immigration realm with really unlocking the power of our information and utilizing that with different analytical platforms, working out of a data lake now, having most of our data in the cloud. It's been really great for us to unlock things like graph use capabilities and services, especially for making relational constructs and doing that type of work. So I've been here for just over a year now. I was with CBP for a couple of years prior to that, and even with our Office of Biometric Identity Management prior to those. So I've had a lot of experience in the immigration world, trying to make our data come together more efficiently, work together. It's been crazy since they kind of broke up INS almost 20 years ago now. So really trying to re-engage, especially since technology has moved us in a direction, moving away from paper into modern processing of information. A lot of transformative things that are way, but happy to be here again today and look forward to a great discussion. Thanks.
Fantastic, thank you. And then, of course, our industry partner, Michael Moore.
Hello, everyone. Thank you for taking the time to be with us today. I'm Michael Moore. I'm Principal Partner Solutions and Technology at Neo4j. I've been with the company about 2 years. Prior to that, I was a Managing Director at EY. I have expertise on graphs, knowledge graphs, graph systems, graph-based artificial intelligence and machine learning. And my team basically helps customers and partners implement the Neo4j Graph Data Platform in a way that drives real value for the organization and its users. Prior to being at EY, I was at Microsoft for about 7 years, and I've been operating in the sort of the globally deployed enterprise analytics space for almost 20 years.
Fantastic. Well, we have such a great group of panelists here today to share their perspectives with us. And we don't necessarily have to go in any particular order. So panelists, whenever you feel like you want to add something to the questions that I'm about to propose, go ahead and use the raise hand icon. Otherwise, I'll just call on you. But Suman, I was hoping you could maybe kind of help kick us off with the first question that I'm about to ask, which is about how can enterprise level data analytics really be used to help government organizations overcome the challenges of data silos, like you mentioned in your introduction, and really help to achieve a more holistic view of operations?
Absolutely. And this is where we started when I joined Copyright Office in 2017. We had a wealth of data. Like I said, we have the biggest repository of copyright data in the world. And I was amazed the kind of information we had. And there was, the people were operating in silos. There were, which I used to call a center of excellence, because they were in themselves really valuable information, very excellent source of information, very much needed for the task they were working for. But each division were working with the same data in a different format, in a different nomenclature, in a different setting. There was lots of redundancy of work. There was lots of overlap, but one team didn't know what the other was doing because there was a segregation, there was security reasons, there were business requirements, a lot of parameters around that. Once we started discovering what data we have, what systems we have within the office, what applications they're using, what is the use to the business owners or the public in general, since we are public-facing enterprise, we publish lots of information that's related to copyright registration and recordation. Once we started discovering that and talking to different divisions and groups and people, we found out they were pretty much doing similar work in a different setting, using same information, but doing the redundant work. So we started consolidating all the databases, all the legacy systems, started looking at their workflows. And once we created an enterprise architecture for the as-is systems, we figured out it was much easier to consolidate into a single source of truth. So people could have information, same information, everybody has the same numbers and same work process flows and things like that. It helps streamline, not only streamline the process, it also reduced the redundancy and waste, and it also made information flow easier and simpler and standardized across the board. So I feel like silos are good if they are just for specific reasons, but breaking the silo and integrating them together to make sure information is flowing from one place to another. The network of information is very important for any kind of data-driven decision making, which is where we are going right now with whether it's artificial intelligence, whether it's KPIs, whether it's the metrics we are reporting. We do need that network of information to flow, not just sit in the silos.
Yeah, thank you, Suman, for kicking us off there. And would any of our other panelists like to weigh in on based on their experience or what Suman just shared with us?
I'd love to. I have an unpopular opinion that not all silos are bad. Indeed, the Department of Defense in many ways is a giant silo for obvious reasons. Not everyone around the world is friendly, and the world can be a dangerous place. I think there's a direct correlation between the size of an organization and the silos that exist. In the context of the Department of the Navy, we're large. We're not as large as the Department of Defense, obviously. We're a subcomponent. But in terms of size, scope, and complexity of missions, just the sheer volume of data that we need to process and the missions that we need to accomplish, in 80 years of behavior after National Security Act of 1947, we have some hard work to do. And the silos existed for a reason in many cases, and in some cases it was just an artifact of what we had to do at a particular point in time to execute a mission at a particular point in time, and it perpetuated. So with that understanding that not every silo is necessarily bad, the problems that you do encounter when you have multiple parts of your organization doing the same work, but slightly differently. So we have lots of folks who do human resources. We have lots of folks who engage in various and sundry logistical activities. It doesn't make a lot of sense to be doing that slightly differently, or processing different data, or having systems that can't talk to each other, fields that a human can't recognize, all of those types of things. The other problem that we have is we can't necessarily stop time and build a modern, robust as is architecture while also needing to answer questions in near real time. So we have to kind of optimize for both, understanding that that's kind of a suboptimal way to operate and to execute. But within all of that, stipulating that and kind of putting it off to the side, the way that we've really started to break down silos is really trying to understand why do they exist, and who are the people in the organizations that have those silos, and trying to understand the missions they've tried to accomplish, why are things the way that they are, and trying to build some trust. It's a much more difficult conversation when you're in a command organization and you walk in and say, hey, we're going to have to kill your system because you're duplicative with this other command over here, without really anything that might replace it, or a plan which looks really good on paper, but you don't necessarily have it tested out. So breaking down those silos, it's not necessarily a technical problem. At least in the Department of the Navy, it is a cultural discussion and a people discussion that we have to have. So we spend a lot of time talking. The overwhelming majority of my days are spent talking to people as opposed to hands to keyboard. So I guess that comes with the nature of the work.
Yeah, thank you, Duncan. Would any of the Michaels want to join in?
I'll just add that silos is by definition one of the biggest challenges in the Department of Homeland Security, given it is the third largest agency. I think I know from my fact book on DHS 101. And really, if you think about it, agencies that really didn't have any organizational ties besides some dual mission operations were brought together roughly 20 years ago. And what that's created from an information technology perspective and applications, databases, you name it, there's a lot of things that are kind of connected, but a lot of missions that are completely separate. So completely get the need for silos for national security purposes and those types of things. But the fact we took one agency, say INS back in the day, and split that into three separate components within CDP, USCIS, and ICE, it's created challenges from a data front standpoint that we actually worked better in some degrees from an information technology perspective. Now we've broken out some legacy systems into 3 or 4 different iterations. And it's important now where technology is that we try and bring that information back together, just not look at it from a separate entity, a separate mission, versus what's going on the border versus what's going on in an immigration service center. All of that information is interconnected, and we don't need to maintain separate copies of the same thing over and over in different places. So breaking down silos is a huge challenge for DHS abroad, but where USCIS is helping lead the way with its information and its work is that centralizing around a data lake, making sure our applications are interoperable, talking with each other, trying to consolidate data sources where possible by not interrupting the mission as much as possible. Those are the goals, and those are the things we're trying to work with our data strategy in USCIS and also implement with our partners. But it's just been such a slog trying to get off, like I said earlier, using paper for processing, and also getting away from mainframes and things that were really popular when many of these immigration systems were developed in the early days, in the mid 1900s. But now we're moving away from those capabilities finally, and trying to get to the 21st century capabilities. But everybody knows how government is not as quick to adapt over time. So I'll just add, yeah, silos definitely something we're working on.
Yeah, thank you.
Sure.
Michael Moore, I know it kind of sucks to be the last person to answer when people.
Yeah, I'm happy to. Yeah,
But-
these are all classic issues that Duncan and Suman and Michael have raised. And I guess what I would maybe try to share is that there's a big difference between information and knowledge. And when you see information architectures where there's a big success around centralizing or pulling together data from a variety of sources, it doesn't necessarily mean that that data is actually in a usable state. And to Duncan's perspective, you have different teams, they define things different ways. And so maybe there is a large data lake, or maybe there is a large data warehouse. And certainly we see this both in with our government customers and our commercial customers. They are, many of these teams are already 10, 15 years down the path of this strategy, and they're still struggling with how do I answer basic questions, like Michael's probably main question is, hey, where can I find this individual, right? Or who is this individual, right? Or maybe Duncan is trying to figure out, we have a mission to execute, and what are our dependencies, right? How do we, what are going to be some of the risk factors? Can I identify all of those risk factors? And so at Neo4j, what we do is we provide a graph data platform. And a graph data model basically creates a data structure where all of the known relationships are computed and stored in that data structure as you load data into it. So it essentially creates a queryable network that can overlay other kinds of data sources like data warehouses, legacy systems, complement data lakes. And one of the interesting things is because of this unifying ability of a graph, it actually forces a lot of conversations around what do we call this entity, right? What's the taxonomy and ontology and semantics that we want to use to describe this particular entity, right? Is it a system? Is it a person? Is it a location, right? And as you work with technologies like Neo, these conversations get forced, definition begins to emerge, and then you're actually moving from, say, consolidated information into actually queryable knowledge. Because now we all have a common understanding of what this entity is, and I can use the graph basically to see all of its contextual relationships to any other's data source that might be contributing to the description or the understanding of that entity. And so this is a very, very common problem. And so this, breaking down silos is a complex piece. You have to get permissions from different data owners to even join data together. And then even having done that, you still have to get common agreement as to what it is we're looking at and how we want to name it and how we want to understand it in its context to other entities. But having done that, then you can begin to answer those basic questions, and you can drive much better relevancy around your understanding of that entity almost in real time. And so we have a lot of customers that are basically streaming data into graphs, but then processing through common semantics so that they can get that instantaneous view of say, what is this individual doing? Who are they? What are their needs, et cetera.
Michael, maybe you can also quickly answer for one of our audience members, Robert Damashek. He asks, can you clarify the difference between a knowledge graph and a semantic data layer?
So the knowledge graph, the way that we think about knowledge graphs is that it's an entity, it's a data system that basically has identified entities, and those entities are shaped using common semantic definitions and taxonomy, so the knowledge graph has that semantic layer essentially built into it as part of its design. But it also does some other things. So for example, it'll represent and simplify all of the important entities in the data domain. It will typically consume transactional data at a low level so that you can get to some kind of a real-time state. And then as I said, it'll be the place where various semantic structures and ontologies and taxonomies are clearly defined and being implemented. And then importantly, it's also being used for inferential analytics. And so the knowledge graph will actually be used to build additional relationships that aren't necessarily known in any other systems by looking at that context around an entity. So if I'm trying to detect fraud, for example, I want to know, here are individuals that appear to have, say, multiple social security numbers, right? That's a problem. Now, I might not know that from looking at any other system, but I bring that together in a graph and I say, I have one entity for social security number, I have one entity for individual. I join those across a pool of transactions that my system is taking in. And now I have a subgraph that basically says, hey, I can immediately find an individual that appears to have 3 or 4 social security numbers in play. That's a problem, right? I'd like to know more about that individual, right? So that's an example. So a knowledge graph basically pulls together these 4 components, the entities, your semantics, transactions, and inference.
Fantastic. Well, thank you all so much. We're going to call for poll question number 1 real quickly, which is, how familiar are you with enterprise level data analytics and its potential benefits for government organizations? So that's for our audience at home. Please respond to that if you'd like to receive your CPE credits.
Well, I still have a job if I say not familiar at all.
We won't tell who said what. So
becoming less familiar, right?
Question number 2, Michael Gorman, maybe you can kick us off here with this next question I want to ask, which is, what are some of the potential challenges or barriers that government organizations may expect to face when implementing enterprise level data analytics? And, maybe speaking to your own experience, like how can these go ahead and be addressed?
Right. So, just to think right off the bat, I think one of our challenges at the DHS enterprise level, and definitely within USCIS, is definitely applying standards, trying to understand different types of iterations of the data that may be, in some cases, the same field, but it's named different instances. So bringing together all that information into, say, your data lake or data warehouse, historically has been a challenge because, to Michael's point earlier, if you could bring it in there, that's great. But what do you do with it? How do you make sense of it? So those are some of the biggest barriers, and really just breaking down the silos of the way our data is constructed from primarily the mission aspects that they're supporting. So I've got a gentleman working on the border, Border Patrol out in the field, doesn't have as much access to information really available. He's processing and apprehending a person for the first time, but they may have had some interaction with CIS. How do we make those linkages? So we've done a great job from, say, some of the user interface capabilities, federated query type searches of mass systems. But from a data integration layer standpoint, being able to make those, those types of connections to anticipate and to have that information actually verified and collated in a way that actually it is the same person and all those things, have had some advances with biometrics as well to help, but it's not necessarily a full complete picture. So dealing with snippets of people's information when you encounter them, and being able to make those sound immigration determinations is where we struggle to necessarily have the whole picture ready for the analyst. And then even if we do have a good portion of that data together, is it displayed or maintained in a way that you're going to see the common linkages by the elements, by the the standards that we're trying to do in our CDO shop? That's the big missing part. And another part of using the analytics platforms that we're running into issues right now, everybody has different numbers. So depending on how their information is being collected, how it's being reprocessed, putting that information forward, stats are different from USCIS versus CBP versus ICE. So we've got some efforts underway to bring together from an analytics standpoint for dashboard capabilities and better visualization tools beyond just an Excel spreadsheet. But we struggle with, what is finding that correct number on how many individuals have entered the United States, or how many people we have processing through the system for a green card. Depending on which avenue and which system source and which application, even which dashboard you're utilizing, there can be variations in the number. I don't know if on the current front, there's a way to fully mitigate those challenges, even with where technology is right now. But I think explaining those differences, trying to get to the decision makers or senior levels of leadership, hey, there are some limitations here. We can present information to you in near real time. But I think folks struggle with, hey, why can't I just get a clear answer on this? Well, it's pretty complex. And bridging those gaps is another area we have to work with. We've got some great technology available, but how do you deal with the historic data, all these things? So I've been all over the place in a couple different challenges and areas, but those are some of the biggest things we have on the DHS, definitely within USCIS, trying to overcome those historical limitations and trying to meet where technology is pushing us now with those capabilities. So.
Thank you, Michael. Duncan or Suman, would either of you like to weigh in next?
Sure, I
Sure.
can go.
Oh, no, you go ahead, Suman.
All right, thank you. So yeah, definitely, I agree with what Michael said. I'm going to add, I have recently set up an enterprise business intelligence system in Copyright Office, and I have faced 3 very major challenges, besides many more of them. The first one is having a legacy system. So the people who build those legacy systems are gone. There's no proper documentation. You just have to do a reverse engineering to understand where the information sits, we have to do the source to target mapping between the application and data, because the application has a different nomenclature than how the data is being housed in those schemas and database structures. So we have to do a source to target mapping. There's no standardized approach for any of the data sets. So we have to look for a data dictionary, which is not adequate. So create your own data dictionary, mapping those information. So at least we understand how the legacy system houses the data, what information sits in there, and how it is being used with the current reporting mechanisms. People are either running queries or having spreadsheets. So you marry that information with the data sitting into the database. So the legacy part of it is a mammoth. We had to do the as-is analysis of the entire system. And then even if you get the data, even if it's there, the data literacy is a huge problem. Not everybody is data savvy. Not everybody understands what to do with the data or has the training or understanding of how to do the analytics or pull the data or even use it in appropriate format. And then the biggest major thing is cultural shift from the getting the information, automating them into KPIs and dashboards and reporting tools. It scares them. It's like, is it taking my job? You're setting up an enterprise system, so am I going to go away? What's happening here? No, it's for the convenience and giving you more ability to do your job. So we had to navigate through all those things to actually make a productive outcome of setting up a data warehouse and a business intelligence tool to create dashboards, to run the KPIs. We get requests from Congress, we get requests from reporters, we get requests from general citizen public, for bulk downloads. So we have to look into the data, and uniqueness of copyright data is our data has to be stored for the life of the author plus 70 more years. And if that registration is shifted to another person, then it shifts, the year shifts from that person's life plus 70 years. So it's like we cannot delete any of the data sets, and any information that we want to look into. In times of litigation, we have to go to 100 years back data. So it has to be readily available all the time. We cannot put it into a cold archive backup. It has to be in a way that it should be readily available. So it is archived, but still available. So there are multiple challenges we have faced and still facing to implement those solutions.
Thank you, Suman. Go ahead, Duncan.
Well, first, a shout out to the library folks. Most of what we do in the modern sense, you can trace back to Callicrates and trying to do things with papyri and books and codices and breaking apart the codex into individual data objects. And now we find ourselves trying to reconstitute things. So it's come somewhat full circle. Very briefly, it's somewhat trite to say, but people, process, and technology. I mentioned the cultural aspects before. Everyone wants to be data-driven until the data tells you something about yourself that you don't find very comfortable or you don't want someone else to know. So one of the things we do in the Department of the Navy is exercise some radical transparency in our efforts. So if we are engaged in any type of data acquisition or analytical effort, we make sure that any methods that we're using, any statistics, this is how we are presenting this data, that those methods, those weights, that is fully open to those involved so they can understand, they can take issue, they can appeal, all of those types of things. The other key challenge that we've had is we're trying to do things now that we didn't necessarily anticipate that we were going to do 5 years ago. We're subject to pretty strict budget cycles, unlike the commercial world where they can turn on a dime if there's a new technology. So 5 years ago, we should have been programming for the things that we're doing now, the various IT modernizations that we need in order to be able to get data out of systems that are critical for us to answer various and sundry questions. So having to answer those questions now and getting data out now and having kind of some suboptimal manual methods, it can be pretty difficult. But if you're very transparent and you give those organizations and individuals the opportunity to look at what you're doing every step of the way, and you're very diligent about identifying, we're doing something manual now, we're going to hold you accountable for some type of modernization to make it easier in the future, some of those problems start to be solved. And we're just starting to see, we're now in my 4th year in the Department of the Navy, some benefits from things we did my first year in being able to acquire data in near real time at speed and at scale for decision making.
Yeah, I guess I would also add that, there's a fundamental paradigm shift that's been going on in data management. So, 10, 15 years ago, it was a centralized activity. People that wrote the queries were, very much experts in the data model, knew how to construct those queries. They were building analysis sort of on a ticket basis. I need this report, I need to look at this. That would get sent up the chain. A couple weeks later, something would come back. Now the paradigm is completely shifted to pushing analytics as a service out to the edges. And most of us in our, when we're not working, we've all interacted with platforms like Amazon, that has a very good idea of what our intention is. And when we want to conduct a search for something. And I think that, in this era of modernization, it's also just as a data service provider, everybody that's on this call, wears that hat. And so now you're seeing a strong interest and need in, can this analysis be stood up as an API so that anybody who is credentialed can actually just go pull this data, right? Can we know that the data that we're distributing into an API is trustworthy? How do we think about some of these other really advanced services that are starting to emerge, like generative AI, right? Is there a role for that in government? And how do we make those kinds of experiences trustworthy when we're distributing data broadly? So I think the conversation has shifted from being, sort of tightly controlled, slow, and cumbersome to being, more of a real time, as Duncan mentioned. How can I actually facilitate decision making across a large number of stakeholders at a speed and in a context that really meets their needs. And so I think that's again calls for different kinds of architectures. It calls for things like in-memory capabilities, data pipelining, API construction, and then there's a big security wrapper around all of this, right? How do you do all of this and actually know that the person or the application that's hitting that API is actually authorized to make that request and receive the response.
Michael, and since I have you speaking, we also had another follow-up question in the chat from Jacqueline Charles. She asks, it's circling back to the graph, with the knowledge graph with semantic model that Michael described, is there a need to maintain a data catalog or business glossary?
Yeah, I would say absolutely. A lot of the graphs that I've been involved in building, they can do that explicitly with with standalone artifacts. Also, they'll do that implicitly through processes like data genealogy. So for example, if I'm pulling data from multiple sources, I can actually track the provenance and genealogy of all of those sources in my knowledge graph. And I can say, this field, Michael brought up the point that I might be looking at the same field or the same concept, and it's named differently in 10 different systems, right? You can keep track of all of that metadata around data provenance and genealogy in your knowledge graph. So you can still run your analytics, you can still run the answers, but if you need to drill down, if you have a question, you can say, where did this piece of data come from? That kind of information is often maintained. And so that would be sort of a virtual dynamic data dictionary and catalog.
I think this other question might be for you as well. Where does data mesh fit with your approach and strategy?
That's a great question. So I have a personal opinion on this. I think data mesh is sort of a retrograde approach that is a response to failed data centralization projects. So a data mesh approach, for those who are not aware, is essentially basically reverting the concept of data stewardship back into smaller teams who have domain over that data environment, and the integration requirement that's associated is severely relaxed, so that there's only certain kinds of queries that you could execute across a data mesh, and you might have a distributed federated query, and it's going to go pull elements of a catalog, and in a few minutes it might come back with some kind of a result. To me, that is it's almost in opposition philosophically with what we're doing with graphs. So in a graph approach, what you do is you say, these are our important data elements. We're promoting all of these into a graph, and we're going to make sure that they're all fully integrated and fully queryable. And then because it's still one single entity, it's very, very fast, and you can validate all of the data that you pulled into it. Whereas I think the data mesh concept, I think it raises more questions than it answers. But maybe Duncan or Suman or Michael, you'd like to comment on that, but that's my personal opinion on that type of thing.
I don't have nearly the same doom and gloom of data mesh and data fabric. My email work gets blown up by various and sundry vendors and even people within the department. Hey, we want to do this. Hey, we want to do that. I think at its heart, and I'll open the kimono a little bit. We do both. I mean, we are so large. No one individual has a subject matter expertise on all data. So we have a concept of 12 information domains. as part of our concept of employment to realize the DoD data strategy and the Department of the Navy implementation plan of that strategy. So having those subject matter experts know that data and be able to get to the point where you have the types of entities, you have the appropriate types of ontologies and semantics, everything's cleaned and controlled, that it's been critical to some of our successes, especially in our enterprise IT operations domain, where we've been able to get those disparate organizations, as you mentioned earlier, Michael, about what's a system, what's an application, what's, a data object, how are we defining, the organizations that do them, what's a transaction, what's an IT purchase request. That's been kind of critical to get those entities specified. We would not have been able to do it without those subject matter experts in that information domain. Now, from a technical standpoint, I won't get into, one mesh to rule them all and all of those types of things, but I think you can square the circle. Maybe it'll blow up in our face. I have absolutely no idea, but it seems to be working pretty well now.
Yeah, I think as long as you have that really good people connectivity, or if you set a standard, you'll know it'll be adopted. I would say that's probably one of the critical components for data mesh success. Right. So that you have some interoperability between your different data domains.
Any other comments here before I call for our poll?
Well, I would like to add, I agree with Duncan. It's always a combination, since if you just talk about the relational databases and applications supporting that may have a data fabric layout, you could have a data center and a DBA team and doing stuff. When it comes to analytics, business intelligence reporting, KPIs and things like that, you may have a combination of data fabric as well as data mesh, since you need that SME expertise. You also need that IT expertise. So it's kind of a combination. I see that at my workplace too.
Yeah, excellent. Thank you. Michael Gorman, did you want to add anything?
No, all great points. I'll just say we need a hybrid too, given our operational data challenges and just the ability to work with multiple SMEs in different areas, even outside of our reach, component-wise amongst DHS. Yeah, we definitely need to look at things. We are using Graph, it's great, but we do need other capabilities kind of associated with the mesh area as well. So we've got to do a hybrid model.
Thank you. All right, poll question number 2 up on the screen here. Has your agency invested in or implemented real-time analytics capabilities? So please take a moment to respond to that. And then I want to get into some examples of successful case studies. So maybe Duncan, if you could kick us off with this question here. What are some successful case studies or examples where you've seen government organizations have utilized enterprise level data analytics to help really drive positive outcomes and improve their overall operations?
Sure. There are a couple that I'm actually very pleased with, and our team has worked very diligently on these. We turn out a lot of policy in the Department of Defense. I mean, federal government, there's just a ton of policy, a ton of regulation. And it is sometimes difficult to keep track of how all of those interrelate, sometimes hard to keep track. Organization 1 says we have authorities to do, this thing, and organization 2 says, no, we do. And you look, and even though it's separate and they're in separate places, you look at the text and it's kind of like, well, yeah, that is pretty much synonymous. How did this ever get through? And it's because you have different elements doing different things in that policy realm. So we, in a couple of efforts within the Department of Defense, have done some robust text analytics to pull out those entities for those policies and those varying versions of those policies over time, to get to the point where we can correlate and see, do we have policies that are in conflict? And we've visualized this in a graph, and we've stored it in a graph. Do we have conflicts of those policies? Who are the organizations that have written those policies? Do those organizations still exist? If that organization no longer exists and there has been a successor organization, does that successor organization have the same missions and functions? So we visualized all of those things and stored all of those things in a graph, and it is made for much better, easier conversations to catch things in the run. Do we know that a policy is currently being updated? Okay, great. Now we know we need to address these issues that we identified previously in that policy or those set of policies. And going further down the road of pairing that kind of robust text analysis with graph, you start getting into scientometrics and bibliometrics. We want to keep track of the research that's out there. So tracking research in academia and elsewhere. We're very lucky in the Department of the Navy that we have a great research enterprise that does those types of things. So if we see something that's promising and new, we can kind of track those concepts. Where did it come from? And you can even extend it into some efforts we're doing with our acquisition, our contracting organizations, to make sure that not only within the Department of the Navy, if we have one contract that's doing one thing on the Navy side, could we realize some efficiencies by not doing the same thing on the Marine Corps side, or extend into other military departments and services? So being able to find those things, and then the beauty of graphs is that they are so conceptually intuitive, and being able to see it, it makes it easier to accomplish those missions.
Thank you. Michael Gorman, do you have anything you'd like to add?
I'll just provide an example, especially where graph is really helping us solve problems that probably weren't as easy to solve a long time ago, but manual and human really hard work and dedication to going through maybe thousands of lines of documents and different things. One of the challenges we have, fraud was mentioned earlier. We have an entire part of CIS dedicated to fraud detection, naturalization services. From that perspective, what Graph is allowing us to do is make not just person-centric identification, which Michael mentioned earlier, trying to find the person, right? Well, now it goes beyond that, trying to find the organization. So from a perspective of, we've got in the immigration realm, if you apply to extend or change your status here in the United States, there's organizational ties to multiple aspects of that process. So you'll have somebody file a petition, maybe on your behalf, an employer, for a work authorization. We have immigration lawyers that are also engaged with identifying parts of the population, working with them to help them traverse through the immigration system. It's really complex law at times. So especially those that are not full U.S. citizens, it's a new realm to even interact with. To be honest, U.S. citizens probably don't know a lot about the immigration process, all the rules and regulations. And then we have other organizations that are also play key. And then it's obviously goes back to the person that is applying for the benefit or the extension. So there have been numerous iterations now that we've identified over the years. Some have made the news in types of schemes to kind of defraud the government and set up, whether it be fake employment capabilities. And what Graph can easily allow us to make those connections so much more easier, just bringing in different entities, different aspects of the data, making those linkages like, hey, we see this address is commonly used over here. It's also associated with this maybe social security or a number that we have. And then tying that, and that we're seeing this employer coming up again and again with these types of people are subject to fall in these categories. So that has really been a game changer, I think, for us, and really trying to dive down and make connections that just simply didn't exist from the way things were, going back to the stovepipe reference, and just in separate applications. Now moving beyond even person-centric capabilities, which is something that we're trying to do now, because everything that we've usually processed has been transaction, event-based centric information. So Graph, I mean, just it's been a game changer with us, allowing to really dive down into cases like fraud and better to detect that from a government perspective.
Excellent, thank you. I was laughing in the corner at my husband because we're going through this process right now. He's not a U.S. citizen. I am. I had no idea about the process, but I will say it actually has been going along pretty fast. So it's great.
Well, that's good to hear. We've had some backlogs coming out of the pandemic and things. So glad to see some processes are working a little quicker than others. But yeah, it's been an uphill climb and definitely a lot of information to go through. So best of luck.
Thank you. All right. Michael Moore, did you want to add anything before I call for our next poll?
Yeah, I mean, I think what both Duncan and Michael are laying out is that, there's an opportunity for government to think of Graph as essentially an analytics system of record. to be able to use it for things like data integration and consolidation, as we've been discussing, metadata management, getting that contextual understanding. And then, there's a whole world of advanced analytics and algorithms that can automate some of these discovery processes and questions, as well as actually managing the analytics workflows and their orchestrations. And, from an organizational perspective, if you make that investment, then you end up essentially having a data asset that can form a collaboration hub, or a set of investigators or a set of APIs can basically be leveraging this same data asset and having that common understanding as to what is the problem. And then you get basically more coherent decision making. To Duncan's perspective, you can identify conflicts, or to Michael's point of view, you can get that extended context and say, is this a problem with this person? Or maybe I'm looking actually at an organization that's functioning as a trafficker, right? So interesting things like that. We see graphs being used in government. Tax agencies across the world are using graphs. One of the largest graphs that we're running right now is for the Army. And they keep every single piece of material that they distribute in a very large graph, along with all of its costs, the vendor that provided it, individual configurations for fleet vehicles like helicopters, tanks, and APCs. And they can, and then they also know all of the metadata around what battalion that piece of equipment is attached to, its service records, and its ultimately its state of readiness in case a decision needs to be made. Intelligence agencies are using graphs. They've been doing it historically for quite a long time for doing things like metadata analysis, cybersecurity, discovering entities of interest. And then over on the health agency side, to Duncan's point around document ingestion, there's lots of stuff happening in life sciences around discovery, and NLP being combined with graphs to consume research, figure out new types of therapies, interactions, and drive collaboration between researchers and and physicians and hospitals that are in the fields that are maybe running clinical trials and things like that. So there's really a lot of applicability, and the core notion here is that this graph can become this analytical asset that has a lot of extensibility and a lot of utility for your organization.
Fantastic, thank you. I'm going to call for poll question number 3, and then we're going to do a round of takeaways from this whole conversation. So poll question number 3 for our audience: how crucial do you think it is for government organizations to keep up with the latest advancements in data analytics to maximize their capabilities and outcomes? All right, so we are nearing the end of our discussion, and I just want to open it up to all of our panelists. We'll go around and kind of share what you think your key takeaway is from this whole conversation, or whatever it is that you really want to leave our audience with. And we will start with Suman, please.
Sure, absolutely. So definitely, the discussions we had is very enlightening, and it's good to know that, all of us are in the same boat. It's not just, me doing struggling things at my organization. It's government, public partner, government and public everywhere is in the same situation. And we are dealing with similar issues with data analytics, moving forward from legacy to the new systems. There are a lot of things that plays the role here. If it's an unfunded mandate, it's not going anywhere. So we have to have some kind of funding to do the work in data management realm. The funding comes in chunks. So are we going to create a whole plan and then move forward based on that? Or are we going to do work in chunks because that's how much is funded and that's how much justification you give? Because with government, there's a lot of things that are associated with funds, approvals, policies, procedures. And by the time we reach to the modern latest technology, the government technology is already obsolete. So how do we keep pace with what's happening outside the government? Do we have the resources? Do we have the people? Do we have the training? We have the resources? A lot of things to consider regarding that, but definitely we have to be ahead of the game. We need to be doing things in this realm, since now that data analytics is there, but people are moving towards AI. Especially here in Copyright Office, we are getting submissions with lots of AI generated work. Are we ready for that? Should we? How do we identify those things? How do we look at what policies governs those? So definitely we have to move in that direction.
Yep. Thank you, Suman. And we will jump to Duncan next.
Sure, I think Suman brought up a good point about funding, and I think one of the most critical things that we can do in government is show value to our organizations and to the taxpayer. And if we, even with suboptimal access to data and organizational problems and silos, we are still showing value in the Department of the Navy and the Department of Defense. So in my heart of hearts, I believe that by showing that value and allowing the savings that we realize by providing that value, we're going to be able to put money back to core mission. So instead of building, the next best data environment, if we get bigger, faster, stronger, we're going to be able to take some of that money and put it towards building better ships, to training sailors and Marines, to augment our ability to bring cyber personnel into the department, all of those good things. So by concentrating on value, and graphs provide a significant amount of value for not much cost, and because they are intuitive, there's not much training. So there's a huge value proposition for the use of graphs and the implementation of graphs in the government context.
Thank you, Duncan. We'll jump to Michael Gorman and then Michael Moore.
And I'll just add to the chorus here is that I think from a value perspective in the government right now, clearly, besides the great people that we have working for us in different missions, our information is right there with our most valuable commodity, especially in the work of immigration and other related cases flowing from the immigration mission here at USCIS. So I think the majority of our budgets are IT related investments. So really from, I think, the transparency subject that was touched upon, highlighting our value to the American people, the taxpayer, showing we're doing stuff with this information is critical. And I think the analytics capabilities that have been discussed today, the platforms that we're using at CIS are helping provide that transparency, whether it be through GAO, OIG audits, or FOIA requests, Freedom of Information Act, all these things that I want to make sure the government's utilizing all the information that it's collecting as efficiently as possible with the proper oversight offices, privacy, security, Office of Civil Liberties. All those things are really important for us to grapple with from a government data steward perspective. And it's good to know, like I think it was mentioned earlier, we all have very similar challenges, whether it's with the silos or trying to transform this data to more usable capability. So it's great to hear colleagues here are doing great work also in the government and trying to solve these longstanding challenges. But really, besides our people, our information is our key. And there's capabilities there. It's going to take a little longer for government to get there, but we are having some successes, and you can see that through dashboards we have online that people can access. They can see how long a I-45 form takes for a green card or a naturalization capability. So we're putting some of that stuff out there, and we're putting out big reports on, like, say, visa overstays. Everybody's asked about for years. So there's things changing now that hopefully allow the American public to see more capabilities into how we're using all this information and spending your money, essentially.
Thank you, Michael. Other Michael?
Sure. Yeah, so I guess what I would say is, so first of all, this graph stuff is not difficult to learn, as Duncan pointed out. You can get it's very intuitive. Any competent team that's been working with data for a little while could basically pick up this stuff very, very quickly. In terms of maybe points to leave you with. Here's a few. So one is that graphs have an unparalleled ability to unify, analyze, and mobilize complex data. They're very well suited to being able to bring together data that's deeply hierarchical, that has many different sort of views or many different types of joins, any kind of work that's recursive, that requires multiple hops, all that kind of stuff, easily handled in a graph. The other thing is that the graph data platforms have really strong analytical capabilities where you can run algorithms and automate a lot of the discovery of patterns that are both common and rare that are sitting in your data. And that'll help you make better predictions or engineer features that you can use for other kinds of machine learning activities, either inside the graph or outside the graph. And then finally, if you make the organizational investment in a graph platform, that can become your analytics system of record, and that'll help support and socialize data-driven decision-making across your organization and set you up for doing things like analytics as a service, where you're pushing out key pieces of information and putting that in the hands of people that are in the field or into the hands of citizens that need that piece of information quickly and accurately.
Fantastic. Well, thank you all so much. We really appreciate it. And our partners, of course, at Neo4j for helping us make today's event possible. If you enjoyed this session, you'll probably enjoy our next one, which will be up on the screen here shortly. But yeah, just thank you again to our panelists and our audience for participating today. We really appreciate it. Oh, and don't forget to respond if you would like to have your CPE credit mailed to you or not. Thanks, everyone.
Thank you, everyone.
Thanks all.
Thank you.